Good evening, everybody. My name is Marie Stanton, the Distillery Manager at Highland Park, and I've been in that role for 5 years, and I would like to introduce to you my colleague, Colin Baird.
Hello, I'm Technical Support Manager for Edrington. We have 3 malt distilleries, one of which is Highland Park. Marie and I work together on projects relating to raw materials and energy. So I'm a mechanical engineer by background, so energy is definitely my strong point.
So I will just move over to the presentation and then we'll get going.
Okay, looking good.
So our topic for discussion this evening is energy in a traditional distillery, and you've seen myself and Colin. So here goes. So Highland Park, it's a very historical and very traditional distillery, and for those of you that are familiar with the site, you're aware that we've been hanging around up here for 222 years. One of the things you might not be aware of is that this site, as you see it in the photograph, and everything that you see on the left-hand side as you come out of Kirkwall is actually listed. So I just want to get that out there as one of the issues that we have in any kind of project, but particularly energy projects, that we're working within a historical and listed building. Highland Park is obviously, as most people are aware, a single malt whisky, but we're also a peated malt whisky. And that key component of our flavour, which distinguishes us from anything else, comes from our home malt or our homemade malt, as we make it here in the distillery. So we have what's quite rare these days within the industry, a floor maltings, where we steep and germinate and then kiln barley, I beg your pardon, to make malt. And to do that, the final stage of the process, the kilning process, we use peat and coke as well. So the peat is where our key critical flavour comes from, and we extract that from our own Hobbister site out towards Orfa. The coke is used to basically provide heat energy to dry the malt back to 5% so that we can use it and store it. There's also a key interaction between the burning of the peat with the coke that changes the actual phenolic profile within the malt, and that's one of the issues that we need to watch very carefully, because obviously that peated flavour is absolutely critical to Highland Park being Highland Park. One of the other things that just mentioned in passing about Hobbister is that we cut our own peat, but we're also in the project of restoration and regeneration out on the hill. Moving on to other energy that we use on site, one of the biggest things that we use within the site is kerosene, and we use kerosene to run 2 boilers like this to generate steam. And that steam is used throughout the site for many different purposes. So we use that in the maltings, we use it to heat the water so that the grain doesn't go into shock. We also use it to clean washbacks, because we have wooden washbacks, so they need to be cleaned using steam and not harsh chemicals that can stay in the wood. And that is a key critical element of maintaining our secondary flavour profile, which is fruity notes within Highland Park. The other key thing that we use steam for is actually processing. So we use steam to heat water so that we're able to mash in at an effective temperature so that the conversion happens in the mash tun. But we also, really importantly, use a lot of steam within the still house. And that's, again, very important to the maintenance of our flavour profile. And again, one of the historical reasons that still houses tend to be copper is because that copper was an effective heat transfer medium. But that, in conjunction with the steam, makes sure that we have the correct spirit profiles moving forward to make a high quality new make spirit. So that's a little bit about what we use and why we use it. So now I'll hand over to Colin to just go back through some of the challenges and how we plan to approach them. And he's going to go through a similar progress, so we'll just use the same picture.
So I'll just talk through the same slides as Marie, but this time with an energy viewpoint. Marie was talking about things very much from the as-is, how things are done today, and you would have picked up we're a single malt brand. It's a premium product, and so liquid quality is absolutely vital in everything we do. So when we're looking at energy, one of the things we're really conscious of is that we don't impact the spirit negatively. And there are certainly technologies out there which we could employ that would greatly improve our energy efficiency, but might have a detrimental impact on spirit quality. So there's a real balancing act here. And I give that as one example, but there's a number of decisions that we need to make along the way. So Marie talked about the listed buildings, and from an energy point of view, in terms of improving our process, that's definitely a very big challenge. One thing the Highland Park distillery doesn't have is a large-scale heat recovery system. In other sites that we have, well, our main other site, Macallan, there we have a heat recovery system, and that allows us to, we put 1 unit of energy in as steam, and we can keep that energy within the process, so the energy will be recovered from one process and used in the next. We use heat exchangers to do that, and it's quite common throughout chemical engineering, but we need to apply this technology now to Highland Park. We've got an outline plan of how we would do that, but the buildings are a big drawback, so that's definitely a challenge that we'll be working on in the next few years. Looking more at the process now, and particularly in the maltings, again, maltings are absolutely vital to the product that we're producing. So they're not going to go anywhere, and we really need to make sure that the changes that we make there don't impact the spirit quality. So number one, the biggest headache, how do you make peated malt without peat? Well, watch this space. There isn't an answer yet, but there are obviously a lot of challenges around using peat in terms of it being a carbon sink. Thankfully, we do have a very efficient use of our peat already, and so in grand scale, the total distillery numbers, the peat is a very small component of our emissions, and so actually in this picture, the coke is our biggest concern. We only use coke because it's the traditional process, but there are definitely a number of options we could pursue to improve that, and we're already looking at one just now. There's a fund which was launched by the British government recently called the Green Distilling Competition, where there's £10 million available for energy efficiency and decarbonisation projects. And we've applied for one of those. So by the end of November, we should hopefully have feedback as to whether we've been successful or not. But to give you a bit of an idea, we're trying to remove the coke from the kiln process using that funding. I think that's the main points for those ones. We're into the still house now, and really this is, of any distillery, 90% of the energy requirement, both electrical or heat, 90% is definitely going to be heat. And that's simply because so much of what we do is boiling water. These stills are, they operate by boiling and separating the fractions that come off. And the medium that we use is steam. Now, that's steam has been common in the distillery industry for many years. There's another option, which would be hot oil. However, for us, it would be a challenge to change away from that, given we already have the infrastructure to handle steam. So what we're looking at there in terms of sustainability is energy efficiency, number one, and we can do that through the hot water recovery system that I mentioned earlier. We can also do it through improved controls. The way that the distillery operates just now is not state of the art. We have improvements that we could make in the control and also in the preheating of some of the liquids. So you don't want to start your still stone cold. You want to start at a reasonable temperature. We could improve the way that we preheat the stills. And really the biggest one in terms of sustainability would be moving away from kerosene, which is what we use to fuel the boiler here. A natural successor would be electricity, since Orkney has a surplus, but we're not going to tie ourselves into one solution just yet. I think we have a number of options and avenues, but certainly the kerosene boiler is a significant headache from a sustainability point of view, and we're definitely exploring opportunities to decarbonise that part of the process. I think I've covered all the main pieces I want to cover off there. I think the message I would leave you with is the two prongs that we're trying to work on. One is the energy efficiency of the site, and the other is the decarbonisation. Okay.
So thank you very much, everybody, for listening. And if there are any questions now, that's when we'll take them. Thank you.
Hello, good evening. I'm Mark Cole from Community Energy Scotland. I've worked with for more than 12 years, and I'm going to briefly talk about energy consumption, especially community value and affordable smart energy use in Orkney. A huge amount of work and activity happened across Orkney over the last decade on a range of different projects, but specifically for today, I'm going to speak about Heat Smart Orkney with Community Energy Scotland with our community partners in Rousey. SMILE, which is also with Rousey and Media and to some degree Shappensy. A trader with similar partners, and ReFLEX, which is a much larger project that's just underway, involving most of our partners and some other private and public partners across Orkney and Development. So this idea of keeping value, you'll hear a lot, and you're hearing more and more about flexibility. So you've got value in smart energy use, but this flexibility. And roughly what does that mean? Normally you'd have generation and you have grid supply, and that supplies the power to a house or a building, and that is then used for things like space heating, hot water and power typically. Flexibility is a name for where you interrupt that straight connection and you separate input into a property from its use. Typically you do that through storage. Ideally, if you want smart control, you need smart flexibility, you need control systems on it, and you often need communication systems so that you can link up with things outside your property, to your own generation or other parties that can get value out of what you're doing. And with this, one of the early examples of flexibility, as you saw, was off-peak energy, where the grid operator gave us economy 7, 10, total control, and put energy into your house that they stored in bricks and your storage heaters for when you could use when you needed it, and that was off-peak energy. We've done a lot of adapted that and looking at using curtailed energy, and I'll talk about that later, making use of that. And more and more, there's opportunity that the grid operator can use your devices to provide grid services, voltage stability, frequency stability, things like this. And if you have your own generation, you can use more of it on site with flexibility. You can actually set, because you don't have to use it straight away when it's available. With intermittent generation, you can store it, you can use it, you can avoid peak import, and you can use more of your own generation on site, creating value. And you can help optimize your systems, your heating systems, reduce losses, and load manage. So if you have the flexibility, you don't have to have huge peaks and things like this, and you can use that to manage your load and the cost of equipment that you have on site. And thankfully for us, a lot of this technology is already available. Quite a lot in our homes. People, if you have modern storage heaters or hot water cylinders or heat pumps, or is becoming available, like the domestic the Tesla Powerwalls that are in Kirkwall, or electric vehicles. Electric vehicles are batteries on wheels, basically, when plugged in, and they themselves can provide this flexibility and storage. And a really clear example of this from the community point of view was the Heat Smart Orkney project, where Rousey had a turbine. It has a 900 kilowatt turbine that was connected to the grid as a commercial turbine as part of the active network. And it's controlled by a measuring point in Redland, just north of Finston there. And basically it's fine when its produce goes into the grid and flows onto the grid off to Orkney and wider places. And it's measured, and the current's measured at that measuring point in 3. If the current gets too much because the turbine is producing too much, the grid turns off or turns down Rousey, which we don't want. So Heat Smart Orkney came along and said, look, in these houses, all these houses and properties on that same bit of grid, we've got flexibility, we've got storage. What we can do is we can put the electricity from the turbine into those properties and store it there for when people need it. And if we do that, not as much flows down the cable, the alarm goes off at the measuring point and the turbine keeps turning. The skill and the aim to do it, though, is to do it when it suits our turbine rather than the other ones on the system. And this is the smart energy, smart flexibility that we've been doing. It's been going quite well. The project started 2 years ago now, and this is an example of it on just a map of it across the North Isles, and you can see those green lines are curtailment events, and these are the heats in storage bricks on the top lines going up, and the temperature in water cylinders on the systems across people's houses, and on the system going from left to right from a couple of years back. The project went live March. It's continued from last year to gather more data, and we have about 70 odd houses still on the system and about 150 devices, which is good. The two turbines are now linked. The ED turbine is now also linked into that system, and we're using the learning experience from these projects to help others. HSO Orkney is actually a company set up by Rousey, where they have their own staff living and working in Rousey, and the staff and skills that used on these projects are now used to help support and inform new projects coming through. And we're working on SMILE, Trader, ReFLEX and Community Energy Futures, taking what we've learned over the last couple of years and helping others and helping it. And it's a really good example of a community solution, hopefully, to help enterprise, and maybe a model for some wider challenges that we face in Orkney and more widely across the world. An immediate follow-on was the SMILE project that some of you will be aware of from that point of view. EU-funded project where Orkney is one of 3 demonstrators, along with the Samso Island in Denmark and Madeira in Portugal. And again, the emphasis in Orkney is taking what we've done in HSO Orkney to use local energy and combat fuel poverty, but this time linking it to newer technology, sometimes harder to produce flexibility, but you get better energy efficiency from things like heat pump and efficient storage. So we're looking at doing this on the other technologies and making them better flexible. We're very much in the deployment stage. These are just some of the devices going into folks' houses. The turbine on the Rousey turbine on the left, and an electrician putting in devices. You can see some smart heat storage there. You can see a high temperature heat pump, batteries, electric vehicle charging, hot water cylinders, much like HSO Orkney, and going across properties across the area. And we're right in the middle of our installs in springtime here, when, like many people in many aspects of life, we got hit by COVID along with others. The participants have been incredibly patient with this. We've not just because quite a few of them are probably in the audience, judging by the people we've had over the last few weeks, but it's a difficult time. But hopefully we've always ensured that people have had heating and things while we go through it. But 90% of the new systems are in, but some need further commissioning just now. It'll take us up to about 150 systems with the HSO ones. And we aim to be fully operational. We've had a great chance with summer and autumn. We're fully operational before Christmas, and we'll really get into the interesting stuff of gathering the data and looking to see how these systems can be improved, the technical partners can look at over the next while, over the next year. Right. And this is now led on to, I say, the larger project of all that hopefully most folk have now heard about, which is ReFLEX, that started last year. We are now Community in Scotland, but we're working with Aquaterra, Solo and EMEC locally, and OIC and Heriot Watt to do a larger project, which is should have an impact and effect across the whole of Orkney. And the principle is integrating across all 3 modalities, so we're looking at both heat, power and transport, and doing large-scale installation across a lot of different technologies and systems across Orkney. And a key part of this is a local commercial offering, which is hoping to offer affordable power, transport and heat to individuals and businesses across Orkney, using and exploiting the flexibility and coordinating this to provide reductions in cost to the householders and participants in the project. And from our point of view as CS, one of the things we're particularly keen on is making sure the local values remain in there, but also that it is equitable and just. A lot of our time has been spent on that as well as passing on learning from our previous projects. And like the transition to net zero that we're talking about more widely, ReFLEX and these sort of projects will work best if everyone can be part. We really believe that. So we've been working through to make sure affordability is a primary aim of the project. We're removing barriers to entry, so there's no big capital costs to stop people with limited means, and socialising of revenue and benefit across the system, and also looking at seeing ways that we can do that. But it's all been formed around the international standards for sustainable development, but also the national standards as well. And Robert touched on those the other week as well, as far as the national performance framework goes. And using our community anchor organisations for active recruitment, but also to provide additional support for those who are more vulnerable and that may not necessarily benefit or get involved in a project like this. Our organisations and partners can actually then help and support them to be involved and be included where appropriate. I just quickly want to finish on the slide here that I've used a couple of times, but I really do like it. It's a simple illustration of things. On the left you see equality, where if the people are facing a barrier, and often a national scheme will give you a box, but it's equality. But a lot of what we try to do, both as communities and as organisations and more locally, is to get something closer to equity, where the solution fits the need in each instance. And you can see that from that illustration. We always have to strive and work to remove the barriers altogether, and that's true liberation. But that's the hardest bit from many ways, and because it's not under our control. But what we can do is, if we, wherever possible, if we work together and include everyone, the people could become part of the solution to the problem, as well as just spectators to it, and often makes the strongest and best way forward. That's it, thank you.